Welcome to Solving Systems by Graphing. Let's get started. Remember that a system of equations is simply two or more equations together. When we translated word problems into a system of equations, like we did on the last video, I talked about how we can solve them. Well, now we're going to start solving them. There are three different solutions that you can get when you solve them. And if you were to graph one equation, and then graph the other equation, and they cross right here at this intersection point, that is their solution. So one of the solutions you could get is simply one solution at the intersection point. The other thing is if you graph the two lines, your two equations, and you get parallel lines. Since they never cross, you would have no solution. So that's another option. The last choice is if you graph this line and then you graph the other equation and they're exactly the same line. That means that they cross all over the place, so you have infinitely many solutions. So a system of equations, when you solve them, you can have three solutions: one solution, no solution, infinitely many. One of the many ways to solve a system of equations is by graphing. So just like I showed you on the last slide, that's what we're going to do here. So we'll start by having our system, y equals 2x minus 4. So we're going to start on the y-intercept. We move up 2 over 1. So we're graphing this first equation. Then we can draw a line. And then we'll go to the other one, y equals negative x plus 2. And since it's negative, we're going down 1 over 1. Down 1 over 1. So there's this line. So you can see they cross. They have an intersection point right here. So that means we have one solution to this system of equations. And that's right here, this point. And you can see that is positive 2. So we went over 2 on the x-axis, and then 0 because we didn't go anywhere on the y-axis. So the solution to this system of equations is 2, 0. Now we can also do this on the calculator. You can enter these two into your y equals button on the calculator and then graph it, and there's a way to find this intersection point. You can look at the table, or there's a couple of steps to actually trace this exact point, which is especially helpful if it's not on nice even numbers, and that we'll go over in class. Now what if we have a system of inequalities? We can still solve them by graphing. So we graphed y is less than or equal to x plus 2. We found the 2, the y-intercept, graphed it with a solid line because it's equal to, and then we shaded less than the line. The other inequality, y is greater than negative 2x minus 3, started at negative 3, moved with the slope, and we wrote our line with the dashed line because it's not equal to. And then we shaded greater than that line. You can see this area is where both of the lines shading meets. So that means this is where your solution is. This part where they're both shaded. So a system of inequalities has many solutions. Any point inside this double shaded area is a solution to the system. Now the part that gets a little tricky are the lines. This solid line, not over here because this is not where they're both shaded, but this solid line in the double shaded area, every point on here is a solution as well, because again, a solid line means equal to. But no points on this dotted line are a solution because it's not equal to. So as a quick summary, to solve a system of equations by graphing, make sure those equations are in slope-intercept form. Graph them, whether on paper or in the calculator. Then, if they're not parallel, which is no solutions, they're not the exact same line, which would be infinitely many solutions, then they have an intersection point. So find that intersection point, whether it's on a graph or again, in class I'll show you how to find the intersection point on the calculator. Then write your answer as an ordered pair, x, y. And with systems of inequalities, the solutions, there are many solutions in that double shaded area. And remember that points on a solid line are a solution. Points on the dashed line are not in the solution. Don't forget to watch the next video where we learn another way to solve a system of equations. Thanks for watching and see you soon.